Have you ever wondered why the night sky is dark? If you think about it for a second, this is not obvious at all. In an infinitely large and homogeneous universe, there should be a star or a galaxy at each point we look at. Therefore, the night sky should be brightly lit. So why is this so? It is true that the light intensity decreases with distance between the light source, a star, and the observer on Earth. But this is fully compensated by the fact that the number of stars increases with distance. With a bit of math and physics, one can show that the total light intensity coming from all stars should therefore be infinite on Earth. Neuroscientists face a very similar problem when they try to interpret the signals they record with electrodes implanted in the brain. How far can such an electrode actually see? How large is the brain region contributing to this signal? Up until recently, the answer to these questions was unknown. Using mathematical models of the brain and computer simulations, we were able to shed some light on this.
The electrical activity of nerve cells is measured with fine electrodes. The change of the electrical potential at the tip of the electrode becomes visible as a curve. This curve shows the electrical activity of the cells. Similar to the starlight, the signal strength of nerve cells decreases with distance. But at the same time, the number of broadcasters located at a certain distance to the electrode increases with the distance. The essential difference between a star and a nerve cell is that signals from the latter get weaker more quickly. Therefore, the reach of the electrode extends only to a few tenths of a millimeter. This is, however, true only if the nerve cells are independently active. As soon as there is some synchrony in the activity, the signals overlap. They interfere and amplify. Therefore, the electrode can see as far as the synchronous activity reaches. This area can measure up to several millimeters. Nerve cells can indeed synchronize for various reasons, for example due to the fact that they partly receive input from identical other cells.
And just in case you are still wondering, the night sky is dark for several reasons. The most important one being that the universe has a finite age and that the light from distant galaxies simply hasn't reached us yet. By the way, the solution to this dark night sky paradox has already been found in the 19th century, without any expensive, sophisticated technology, just with the unarmed eye and common sense.